Welcome to David Alexander Maths Tuition. This is chapter 12D on differentiating quadratics. So find dy by dx given that y equals 3x squared plus 2x plus 9. Okay, dead easy. Again, all we're doing is differentiating each bit one bit at a time. So 3x squared becomes 6x. Now 2x, remember 2x is 2x to the power of 1, so that's 1 times 2, which is 2, and x to the power of 0. But anything to the power of 0 is 1, so that is 2 times by 1, which is 2. So this is just 6x plus 2. You'll get into the habit of just knowing that 2x, or any number of x, just becomes, the derivative is just the number itself, so that we lose the x. And 9 just vanishes. Now 9 is, we can write that as 9x to the power of 0. So what we've got here is, if we're differentiating 9x to the power of 0, 0 times by 9 is 0, so that's 0 times x to the minus 1. But 0 times anything is 0, so the 9 just becomes, well, plus 0, and we might as well just forget about it. So remember that a 2x just becomes a 2, 7x becomes a 7, minus 11x becomes minus an 11, and plus any number, well, that just vanishes completely. So here, dy by dx, our gradient function, is 6x plus 2. Find the gradient of the curve with equation y equals this stuff here at the point 3, 7. So if we want to find the gradient, we need the gradient function, which is dy by dx. So we need to differentiate this equation. So 5x squared becomes 10x, 2x becomes plus 2, and we can forget the negative 7. Now, we don't actually need the y coordinate, we just need the x coordinate, which is 3. So what is the value of the gradient where x is 3? Well, I'm going to substitute it into the dy by dx, which hopefully you'll remember is the gradient function. So when x is 3, the gradient is 10 times by 3 plus 2, so 32. So the gradient is 32. Find the coordinates of the points on the curve with equation 3x cubed plus 2x squared plus 5x where the gradient is 98. So whenever a question talks about gradient, you probably need to be thinking about differentiation. So dy by dx is going to be 9x squared plus 4x plus 5. So this is my gradient function. This is the equation I use to calculate the gradient at any given point. But here I know what the gradient is, it's 98. So what I'm going to do is I'm going to make 9x squared plus 4x plus 5, I'm going to set it equal to 98. So now what I'm going to do is subtract 98 from both sides. So 9x squared plus 4x, take away 93 equals 0. So I've got a really horrible looking quadratic, so I'm definitely not going to attempt to try and factorize it. I'll just use the quadratic formula calculator on my calculator. So A is 9, B is 4, and C is negative 93, and unbelievably I'm getting that x is 3. Are there any other points? Okay, yeah, and x is minus 31 over 9. So there's two points where the gradient is 98. Now when we've been asked to find the coordinates, so I found x is 3. Now this is where people get tangled in knots. People want to substitute it back into the gradient function, but we know that if I substitute it into here, I will get this value of 98. I'm trying to work out the coordinates of a point on the curve, so that is the points on the curve fit the equation 3x cubed plus 2x squared plus 5x. So I need to substitute my 3 into this equation here. So 3 times 3 times 3 times 3 plus 2 times 3 times 3 plus 5 times 3, y is 114. And for the negative 31 over 9, I'll do a shortcut. Just type in minus 31 over 9 on my calculator and just do 3 answer cubed plus 2 answer squared plus 5 answer. And I'm getting something pretty horrific. Y equals minus 28210 over 243, which is a ridiculous fraction. You can tell that this question's been invented by me, not by a textbook or an exam board, where presumably you'd get far less stupid fractions. Okay, find the gradients of the curve x squared plus 8x plus 18, where the curve meets the line y equals 3. Okay, so we've got two we've got two functions here, y equals x squared plus 8x plus 18, and y equals 3. So let's find the points of intersection. So that's going to be where x squared plus 8x plus 18 equals 3. Subtract 3 from both sides. And now I can factorise and solve. So x plus 5, x plus 3 equals 0. So the solutions are x is negative 5 and x is negative 3. So these are the coordinates where the two lines meet. So there's my quadratic curve. There is my line where y equals 3. So I've got minus 5 and minus 3. So I need to know the gradient here and here. Now, just because I've done this sketch doesn't really mean anything. I'm just trying to help you understand what's going on here. So I want to find the gradient on the curve x squared plus 8x plus 18 when x is negative 5 and also when x is negative 3. So therefore, I need to find out the dy. I need to find the derivative of x squared plus 8x plus 18. So that's going to be 2x plus 8. Now when x is minus 5, the value of d, so when x is minus 5, the gradient function is going to be 2 times minus 5, which is minus 10 plus 8, negative 2. So when x is minus 5, the gradient is negative 2, and when x is negative 3, dy by dx is negative 3 times 2 minus 6 plus 2, positive 2. There we go.